February 20th, 1942. The morning broke over Pearl Harbor with a clarity that made Seaman First Class Thomas Eugene Whitmore wish he'd never been assigned to optical reconnaissance. 74 days had passed since the attack that killed 2,403 Americans, and the Navy was still counting ghosts. Thomas stood on the hastily repaired dock of Ford Island, squinting through the new Mark 14 naval rangefinder they'd shipped from California, when he saw something that made his blood run cold. Not because of what was there, but because of what shouldn't be possible. The horizon bent wrong. He'd been a sailor for 3 years, trained at Great Lakes Naval Station in Illinois, and had memorized every manual on optical equipment the Navy possessed. Horizons didn't curve upward at the edges. They didn't shimmer with a geometric precision that looked almost manufactured. Yet through the enhanced lenses of the rangefinder, calibrated to spot enemy vessels at unprecedented distances, the line where sky met ocean seemed to ripple with an architectural quality that defied natural law. Thomas adjusted the focus ring with trembling fingers, his palm slick against the brass housing. The device was a marvel of 1942 engineering, compound lenses ground to specifications that pushed the boundaries of what optical science could achieve. It could theoretically spot a destroyer at 28 miles in perfect conditions. These were perfect conditions. The Pacific stretched before him like hammered steel under the morning sun, and the rangefinder was showing him something impossible. "Whitmore, you planning to romance that equipment or actually use it?" Lieutenant Commander Harold Vickery's voice cut through his concentration like a torpedo through water. The officer strode across the dock, his shoes clicking against wood that still smelled of fresh creosote from the repair crews. Vickery had survived the attack by pure chance. He'd been in Honolulu visiting his sister when the Japanese bombers arrived. The guilt of survival had carved new lines into his 42-year-old face. "Sir, I'm seeing something unusual," Thomas said, not moving from the rangefinder. "The horizon's displaying some kind of optical anomaly. Could be atmospheric distortion, but I've never seen refraction pattern like this." Vickery's skepticism was palpable. The Navy had no patience for uncertainty in February of 1942. They were losing the Pacific. The Philippines were falling. Wake Island had fallen. The Japanese had taken Singapore just 5 days ago, a catastrophe that Churchill himself had called the worst disaster in British military history. According to intelligence reports circulating through Naval Command, which Thomas had glimpsed while delivering reconnaissance data to the communications office, the Allies were on their heels across every theater. This context regarding Allied losses in early 1942 is drawn from declassified naval intelligence summaries from the period. Every sailor at Pearl Harbor understood that America's survival in the Pacific depended on seeing the enemy before the enemy saw them. That made optical reconnaissance not just important, it made it existential. "Let me look," Vickery said, his tone softening slightly. He'd learned in the weeks after December 7th that dismissing junior officers' observations could cost lives. He bent to the rangefinder, adjusted his stance, and peered through the eyepiece for 30 seconds that stretched like hours. When he straightened, his face had gone the color of old ash. "Get Captain Morrison," he said quietly. "Right now." February 21st, 1942. Captain James Arthur Morrison III had commanded destroyers in the Atlantic before Pearl Harbor, and he approached problems like a chess master anticipating moves 6 plays ahead. He stood in the cramped optical analysis room they'd established in what used to be a supply warehouse, studying the photographs Thomas had taken through the rangefinder's camera attachment. 12 prints lay spread across the table like evidence at a crime scene, each one showing the same impossible phenomenon. A horizon that curved with mathematical precision, rising at its extremities as if the ocean itself were being bent by invisible hands. "Explain to me again what I'm looking at, Whitmore," Morrison said, his Virginia accent flattening the words. The captain was 51, with gray temples and eyes that had seen U-boats in the North Atlantic. Nothing about his demeanor suggested he was a man easily rattled, yet his right hand kept returning to the photographs, touching them as if to confirm they were real. Thomas stood at attention, his notes clutched in one hand. "Sir, the Mark 14 rangefinder uses a coincidence range-finding system with enhanced magnification. approximately 40 times standard optical range. When I calibrated it yesterday morning at 0700 hours, everything appeared normal. But by 0830, I began observing this curvature anomaly. Initially, I assumed it was a refraction phenomenon, heat distortion or atmospheric lensing. But, Morrison prompted. But refraction doesn't produce geometric consistency, sir. I've taken measurements every hour since first observation. The curvature maintains an exact parabolic arc that doesn't vary with temperature, humidity, or time of day. That's not natural atmospheric behavior. Lieutenant Commander Vickery, who'd been standing by the window watching work crews repair the USS Pennsylvania in Dry Dock 3, turned to face them. I've contacted Naval Intelligence at Pacific Fleet Headquarters. They're sending someone from their Technical Analysis Division. Should be here by 1400 hours. Morrison nodded slowly, his gaze still fixed on the photographs. Has anyone else observed this phenomenon? I checked with the observation posts on Hickam Field and the ones on the hills overlooking the harbor, Vickery said. No one's reported anything unusual, but they're not using enhanced optics. They're relying on standard binoculars and Mark 8 rangefinders, older equipment with maybe 12 times magnification at best. The implication hung in the air like smoke. Whatever they were seeing required the most advanced optical equipment the Navy possessed. It was invisible to standard observation. That made it either an equipment malfunction or something far more disturbing, a phenomenon that existed at the edge of human perception, visible only when you pushed the boundaries of what eyes could see. Thomas cleared his throat. Sir, with your permission, I'd like to propose a test. If this is an equipment malfunction, it should be specific to our rangefinder. If we requisition additional Mark 14 units from other vessels or installations, and they show the same phenomenon, we can rule out local equipment failure. Morrison considered this, his jaw working as he thought. Outside, the sounds of Pearl Harbor's resurrection continued. Hammers against steel, welding torches hissing, the shouts of work crews rebuilding what the Japanese had destroyed. The Navy had lost 18 ships here on December 7th, 8 battleships damaged or sunk, 188 aircraft destroyed. The Pacific Fleet had been gutted in a single morning. They couldn't afford to ignore anything unusual, no matter how impossible it seemed. Approved, Morrison said finally. Vickery, get on the horn to every installation within 50 miles. I want every Mark 14 rangefinder we can access pointed at that horizon within 24 hours. If this is real, I want confirmation. If it's equipment failure, I want it documented so we can alert the Bureau of Ordnance. Vickery saluted and left the room at a pace just short of running. Morrison turned back to Thomas, and something in his expression had shifted, the chess player seeing a move he hadn't anticipated. Off the record, Whitmore, what do you think you're seeing? Thomas hesitated. He'd joined the Navy to serve his country, not to question the fundamental nature of reality. But standing in that warehouse, looking at photographs that defied everything he'd learned about optics and observation, he found himself saying words he'd never expected to speak. Sir, I think we're seeing something that's always been there. We just finally built equipment good enough to see it. February 22nd, 1942. By noon, 8 Mark 14 rangefinders were positioned at strategic points around Oahu, from Kaneohe Bay Naval Air Station on the windward side to Barber's Point on the southwestern coast. Thomas coordinated the observations from Ford Island, speaking to operators through field telephones that crackled with static and the weight of impossible findings. Every single rangefinder operator reported the same phenomenon. The horizon curved upward at its extremities with geometric precision that remained constant across time and atmospheric conditions. At 1300 hours, Naval Intelligence arrived in the form of Commander Patricia Helen Ashford, a mathematician from MIT who'd been recruited into cryptographic analysis 6 months before the war. She was 34, tall, with dark hair pinned in the regulation style, and eyes that evaluated Thomas like he was an equation to be solved. She'd brought 2 civilians with her, Dr. Samuel Rothstein from Caltech's physics department, and Dr. Margaret Chen, an optical specialist from Kodak's research division in Rochester. The warehouse had been cleared of everyone without top-secret clearance, leaving only this small group surrounding the table where Thomas's photographs now competed for space, with charts, slide rules, and what looked like advanced mathematical texts. Commander Ashford spread out her own documents, classified reports Thomas wasn't supposed to see, though he caught glimpses of phrases that made his skin prickle. Observational anomalies in long-range reconnaissance, unexplained optical phenomena in Pacific theater, atmospheric curvature inconsistent with standard models. "This isn't the first time," Ashford said without preamble, her Boston accent clipped and precise. "We've had 3 separate reports of similar observations since January. One from a B-17 crew flying reconnaissance over the Marshall Islands, one from a submarine periscope operator near Midway, one from an Army observation post in Alaska. Until now, we dismissed them as equipment malfunctions or observer error, but 8 independent confirmations using different units of the same equipment model suggests we're dealing with something reproducible." Dr. Rothstein, who looked like he'd rather be anywhere but a military installation, adjusted his wire-rimmed glasses and studied the photographs with the intensity of a man who'd spent his life questioning reality. He was perhaps 45, with the slight stoop of someone who'd spent too many years bent over laboratory equipment. "The mathematics are disturbing," he said quietly. "If we calculate the implied curvature based on these images, assuming the rangefinder's magnification is accurate, we're looking at a distortion that suggests the Earth's curve is more pronounced than our current geodetic models predict." "Which is impossible," Dr. Chen interjected. She was younger than Rothstein, maybe 30, with the practical demeanor of someone who'd spent years translating theory into functional technology. "We've measured the Earth's curvature through multiple methodologies: astronomical observations, geodetic surveys, even the shadows of well shafts at different latitudes. The planet's radius is approximately 3,960 miles. That's not speculation, it's measured fact. For the horizon to curve as shown in these photographs, the Earth would need to be significantly smaller, perhaps 2/3 its accepted size." Silence filled the warehouse. Outside, a work crew was using a crane to lift a damaged gun turret from the USS West Virginia, and the mechanical groaning of stressed metal provided an oddly appropriate soundtrack to the dissolution of certainty. Captain Morrison, who'd been listening from his position near the door, spoke with the careful deliberation of a man walking through a minefield. "Are you suggesting our planet's size has been incorrectly calculated?" "I'm suggesting," Rothstein said slowly, "that what we're observing is inconsistent with accepted models. There are only a few possible explanations. First, equipment malfunction affecting all units uniformly, which seems statistically improbable. Second, an unknown atmospheric phenomenon that produces consistent optical distortion across vast distances and varying conditions. Third, our baseline assumptions about observation and measurement contain errors we haven't accounted for." "There's a fourth possibility," Ashford added, her voice carrying a weight that made everyone turn to look at her. "Something about the enhanced magnification itself is revealing characteristics of reality that aren't visible at standard observation scales. In quantum mechanics, we've learned that the act of observation affects what's being observed. Perhaps high-powered optical equipment introduces its own form of observational distortion, one that's reproducible precisely because it's inherent to the technology." Thomas found his voice. "With respect, Commander, I've been trained in optical theory. Magnification doesn't create phenomena that aren't there. It only reveals what's too distant or too small to see with the naked eye." "That's what we believe," Ashford agreed. "But belief isn't proof. And we're currently looking at proof that contradicts our beliefs. The theoretical framework being discussed here touches on principles that wouldn't be fully articulated until later developments in observer effect physics, though the foundational questions were already present in early quantum theory discussions of the 1920s and 30s. February 23, 1942. Dr. Rothstein requested access to the Pacific Fleet's historical archives, and by morning he'd assembled a timeline that turned the impossible into the inevitable. He spread his findings across the warehouse table while rain hammered against the tin roof, turning Pearl Harbor into a gray watercolor outside the windows. The Japanese submarine I-70 had been sunk near Oahu in December, and its wreckage still sat on the ocean floor, a reminder that enemies lurked both visible and invisible. I've been approaching this backward, Rothstein announced, his energy transformed from reluctance to something approaching manic enthusiasm. He'd been up all night, judging by the coffee stains on his shirt and the wild state of his hair. I was treating this as a novel phenomenon, but it's not. It's a historical pattern we've been misinterpreting for centuries. He pulled out a leather-bound journal, its pages yellowed with age. This is from the archives at Annapolis. Personal log of Captain Richard Mayhew of the British Royal Navy, dated 1793. He was commanding HMS Resolution during a survey mission in the South Pacific. Listen to this entry. Through the new achromatic telescope acquired in Portsmouth, the horizon presents a most peculiar aspect. Where one expects the customary line of demarcation betwixt sea and sky, I observe instead a gentle arcing, as though the ocean's edge were turned upward like the rim of a great dish. I have consulted with the ship's surgeon, who assures me my eyes are sound. The phenomenon persists. Dr. Chen leaned forward, her skepticism evident. One observation from a single captain doesn't establish a pattern. Achromatic telescopes of that era were notoriously imperfect. Chromatic aberration could produce all sorts of optical distortions. Which is why I kept digging, Rothstein said, pulling out more documents. 1827. Report from the USS Vincennes during an Antarctic expedition. Enhanced optical equipment, the best available at the time, showing unusual curvature characteristics at extreme distances. 1861. Confederate blockade runner captain's log describing strange bending of the horizon when viewed through captured Union Navy rangefinder. 1898. Spanish-American War. Multiple reports from both American and Spanish vessels about optical anomalies when using newly developed coincidence rangefinders. He spread out a chart he'd constructed, plotting technological advancement on one axis and anomalous observations on the other. The correlation was undeniable. Every major leap in optical technology had been accompanied by reports of horizon distortions that were dismissed, forgotten, or attributed to equipment problems. Commander Ashford studied the chart with the intensity of someone seeing a code break open before her eyes. You're suggesting there's a threshold effect. Below a certain level of magnification and optical precision, the phenomenon isn't visible. Above that threshold, it becomes observable. And we've just crossed that threshold with the Mark 14 rangefinder. Precisely, Rothstein confirmed. And here's what disturbs me. The United States Navy isn't the only organization that's crossed this threshold. The Germans have the Zeiss 8-meter rangefinder. The Japanese have their Type 94 director system. The British have their bar and stroud equipment. If we're seeing this, they're seeing it too. Or they will be soon. The implications crash down like a collapsing building. Captain Morrison moved to the window, watching the rain sheet across the harbor where the USS Arizona still lay partially submerged, a tomb for 1,177 men. When he spoke, his voice carried the weight of strategic thinking shaped by decades of naval service. If this is a reproducible phenomenon tied to technology level, then it's not a military secret we can keep. It's a scientific reality that multiple nations are independently discovering. The question isn't whether this information will spread. It's what we do with it before our enemies understand it better than we do. Thomas felt the room's attention shift to him, though he wasn't sure why until Morrison continued. Whitmore, you made first observation. You documented it properly instead of dismissing it. That shows judgment. I'm assigning you to this project full-time, effective immediately. Whatever this is, we need to understand it before someone else weaponizes it. Weaponizes a horizon distortion, sir? Thomas asked, unable to keep the confusion from his voice. Dr. Chen answered, her expression grim. Information is always a weapon, Seaman. If the fundamental assumptions we make about observation and measurement are wrong, then everything built on those assumptions, navigation, targeting systems, strategic planning, becomes unreliable. If one side understands this better than the other, they gain an advantage that could decide the war. February 26, 1942. The USS Nautilus surfaced 3 miles off Ford Island at dawn, her conning tower breaking through water the color of lead. She'd been on patrol near Japanese-held Wake Island for 3 weeks, and her crew had something to report that couldn't be trusted to radio transmission. Thomas stood on the dock as sailors secured the mooring lines, watching Commander William Brockman descend from the submarine with the careful movements of a man who'd spent too long in confined spaces. The briefing convened an hour later, with Brockman still smelling of diesel fuel and the peculiar metallic staleness that submarines carried. He'd brought his executive officer, Lieutenant David Hurt, and their navigation officer, Lieutenant Junior Grade Robert Moore. All three men had the haunted look of submariners who'd seen too much and survived too long. We observed the phenomenon through our periscope. Brockman began without preamble. He was a tall man, 42 years old, with a reputation for aggressive patrol tactics that had earned him both commendations and reprimands. February 18th, approximately 0530 hours, position 14 degrees north, 167 degrees east. We'd surfaced to charge batteries and was conducting standard horizon surveillance when Moore noticed something unusual through the Type 8 periscope. Moore, who couldn't have been older than 25, pulled out a notebook filled with meticulous observations. The periscope magnification is only 6 power, significantly less than the Mark 14 rangefinder. But at that magnification, in perfect atmospheric conditions, I observed what I initially cataloged as atmospheric distortion. The horizon appeared to rise at its extremities by approximately 0.3 degrees. I checked against our navigational charts, accounting for Earth's curvature and our height of eye at periscope depth. The math didn't work. Dr. Rothstein, who'd barely slept since arriving at Pearl Harbor, seized on this immediately. You calculated the expected horizon distance based on standard geodetic models? Yes, sir. At periscope height, approximately 10 feet above water level, the horizon should appear at about 3.87 miles in standard conditions, but the optical appearance through the periscope suggested either a closer horizon with more pronounced curvature or— Moore hesitated, clearly uncomfortable with the conclusion he'd reached, or our baseline assumptions about Earth's curvature are incorrect. Lieutenant Hurt spoke up, his voice carrying the flat affect of exhaustion. Sir, with respect, this isn't academic for us. Submarine warfare depends on precise calculations. How far we can see, how far we can be seen, the geometry of approach angles and torpedo solutions. If our observational models are wrong, even by small margins, it affects everything from periscope detection range to firing solutions. Men die when the mathematics fail. Commander Ashford had been making notes, her fountain pen scratching across paper with mechanical precision. Did you observe any correlation between the phenomenon and time of day, weather conditions, or geographic location? That's what disturbs us most, Brockman said. We conducted observations over 6 days, multiple locations across the Pacific. Weather varied from perfect clarity to moderate overcast. Temperature ranged from 72 to 84 degrees. The phenomenon remained consistent. Whatever this is, it's not weather dependent. Captain Morrison had been studying a map of the Pacific, marking the Nautilus's patrol route with a grease pencil. The line traced through waters that were now contested territory. American submarines hunting Japanese ships, Japanese destroyers hunting American submarines, all of it happening in an ocean that apparently didn't behave the way they'd been taught. The Japanese have excellent optical equipment, Morrison said quietly. Zeiss-built rangefinders, high-quality periscopes. If we're seeing this, they're seeing it. And if they understand it before we do— He didn't finish the sentence, he didn't need to. Everyone in the room understood the stakes. The Battle of the Java Sea had happened just 3 days ago, an Allied defeat that cost 1 Dutch light cruiser, 1 Australian light cruiser, and multiple destroyers. The Japanese were winning the Pacific, and they were winning it with superior coordination, superior tactics, and increasingly superior intelligence about how to operate in this theater. Historical records from this period indicate that Allied naval forces were indeed experiencing unexpected difficulties with long-range observation and targeting, though these were typically attributed to atmospheric conditions or equipment limitations rather than fundamental measurement discrepancies. Thomas felt compelled to speak, though protocol suggested he should remain silent. Sir, what if this isn't about the enemy understanding something we don't? What if it's about everyone operating under the same false assumptions, and whoever figures out the truth first gains the advantage? The silence that followed was broken only by the rain, which had returned with renewed intensity, drumming against the warehouse roof like urgent telegraph keys, spelling out a message no one could decode. Dr. Chen finally spoke, her voice thoughtful. There's a mathematical principle called scale invariance, the idea that certain properties remain constant regardless of the scale at which you observe them. What if the opposite is true here? What if observation itself changes based on the precision of the instrument? Not because the instrument distorts reality, but because reality has layers that only become visible at certain observational thresholds? That's metaphysics, not physics, Dr. Rothstein objected, though his tone suggested he wasn't entirely convinced by his own argument. No, Ashford countered. That's quantum mechanics. Heisenberg's uncertainty principle tells us that observation affects the observed. Maybe that principle applies at scales larger than subatomic particles. Maybe the very act of looking more precisely changes what we're capable of seeing. March 2, 1942, Major Frank Andrews brought his B-17 Flying Fortress down through scattered clouds above Hickam Field, the 4 Wright Cyclone engines throttling back as the bomber descended toward the runway. He'd been flying reconnaissance missions over the Pacific since mid-January, and he'd requested this meeting personally after reading the classified bulletin about observational anomalies that had circulated to all patrol commanders. By 1400 hours, Andrews sat in the briefing room with his bombardier, Captain Ernest Miller, and his navigator, First Lieutenant George Reynolds. Andrews was 38, a career Army Air Corps officer with 5,000 flight hours and a reputation for methodical observation that had served him well in the reconnaissance role. He'd brought photographs, dozens of them, taken from various altitudes over the course of 6 weeks. We started noticing it in mid-January, Andrews explained, spreading the photographs across the table. They showed vast expanses of Pacific Ocean photographed from altitudes ranging from 8,000 to 25,000 feet. Miller was conducting practice bombing runs using the Norden bomb sight, the Mark 15 model, latest version. The bomb sight uses sophisticated optics for target acquisition, and Miller started reporting what he called horizon inconsistencies. Miller, a compact man of perhaps 30 with the intense focus of a specialist who'd spent years mastering a single instrument, leaned forward. The Norden sight is accurate to within 75 feet from 25,000 feet altitude in perfect conditions. It achieves that precision through complex optical and mechanical systems that account for aircraft speed, altitude, wind drift, and Earth's curvature. But in January, I started getting calculation errors that didn't make sense. He pulled out a technical manual for the Norden bomb sight, its pages flagged with dozens of bookmarks. The site's computer, the mechanical calculating system, uses Earth's radius as a constant, 3,963 miles. But when I used the enhanced optical system to verify targeting solutions, the horizon appeared at distances inconsistent with that radius. Initially, I assumed calibration error, but recalibration didn't fix it. The sight was working perfectly. The problem was that the optical observations didn't match the calculated predictions. Lieutenant Reynolds, who'd been quiet until now, added his navigation perspective. I've been navigating by celestial observation for 7 years. The mathematics of celestial navigation depend on precise understanding of Earth's geometry, how the planet curves, how that curvature affects horizon distance and angular measurements to celestial bodies. In February, I started noticing discrepancies between calculated positions based on sextant readings and actual positions confirmed by landmarks or radar. Small discrepancies, less than a mile typically, but consistent. Dr. Rothstein had been making rapid calculations on his ever-present slide rule, his fingers moving with practiced efficiency. If your observations are accurate and we assume the optical systems are functioning correctly, the implied Earth radius would be approximately... He paused, checking his calculations twice. Approximately 2,600 miles. That's a 34% reduction from accepted values, which is absurd, Dr. Chen said flatly. We've measured Earth's circumference through multiple independent methods. Eratosthenes calculated it in 230 BC using shadows and geometry. Modern surveys confirm it. Satellite observations. She stopped, realizing her error. Well, not satellite observations yet, but the principle stands. The planet's size isn't unknown or uncertain. It's measured fact. Commander Ashford had been studying the photographs with a magnifying glass, examining the horizons captured from various altitudes. Unless, she said slowly, we've been measuring something other than what we think we've been measuring. What if the Earth's size hasn't changed, but the relationship between observation and reality operates differently than we've assumed? Major Andrews cleared his throat. Ma'am, with respect, I'm a pilot, not a philosopher. But I can tell you this. When the bomb sight says the target should be at a specific bearing and distance, and the enhanced optics show it at a different position, one of two things is true. Either our instruments are wrong or our understanding of how observation works is wrong. Given that these instruments were built by the best engineers in America using centuries of accumulated scientific knowledge, I'm inclined to suspect the latter. Captain Morrison had been conspicuously silent throughout the presentation, but now he stood and walked to the wall, where they'd mounted a large map of the Pacific. Red pins marked locations where the phenomenon had been observed: Pearl Harbor, Wake Island, the Marshall Islands, various submarine patrol positions, and now multiple aerial reconnaissance points. The pins formed a pattern that covered thousands of square miles of ocean. "We need to inform Admiral Nimitz," Morrison said, referring to Chester Nimitz, Commander-in-Chief of the Pacific Fleet. "This has moved beyond equipment anomalies or optical curiosities. If our observational models are compromised, it affects every aspect of naval operations: navigation, gunnery, aircraft bombing accuracy, submarine warfare. We're fighting a war with instruments and calculations that may be fundamentally flawed." Thomas, who'd been documenting everything with the meticulous attention to detail that had first brought him to Morrison's attention, felt compelled to ask the question everyone was avoiding. "Sir, what happens when we tell the Admiral that we think the Earth might not be the size we think it is? That sounds like—" He paused, searching for words that wouldn't sound insubordinate. "That sounds insane, sir." Morrison's smile was grim. "Seaman, in December we thought Pearl Harbor was safe. That sounded like common sense. Then, 200 Japanese aircraft proved us wrong, and 2,000 Americans died because we trusted our assumptions. I'd rather sound insane and investigate the truth than sound reasonable and watch men die because we ignored evidence that challenged our beliefs." March 5, 1942. Admiral Chester William Nimitz sat behind his desk at Pacific Fleet Headquarters, his expression revealing nothing as Captain Morrison delivered a briefing that challenged every assumption upon which naval warfare had been built. Nimitz was 57 years old, a Texan who'd commanded submarines before rising to fleet command, and he possessed the rare quality of being able to consider revolutionary ideas without either dismissing them reflexively or accepting them uncritically. The briefing room contained the accumulated evidence of 3 weeks' investigation: photographs, mathematical calculations, observer reports from multiple platforms and locations, historical documentation suggesting this wasn't a novel phenomenon, and most damning of all, a demonstration using a Mark 14 rangefinder positioned outside the window, showing in real time the horizon's impossible curvature. When Morrison finished, Nimitz stood and walked to the rangefinder, spent 2 minutes making his own observations, then returned to his desk without comment. The silence stretched until it became almost unbearable. "Gentlemen, Dr. Chen, Commander Ashford," Nimitz finally said, his voice carrying the measured cadence of careful thought. "What you're describing represents either the most significant equipment failure in naval history or a fundamental misunderstanding of observational physics that has persisted for centuries. I'm inclined to believe it's neither." He pulled out a folder marked with classification stamps Thomas couldn't read from his angle. "I've received similar reports from 3 other theater commands. The Atlantic Fleet has documented optical anomalies when using high magnification equipment. The British Admiralty sent a classified communication 2 weeks ago describing what they called enhanced observation discrepancies in their North Sea operations. Most interestingly, we've intercepted Japanese naval communications." He paused, seeming to decide how much to reveal. "Let's just say we have reason to believe the Imperial Japanese Navy is also investigating similar phenomena." Commander Ashford leaned forward. "Sir, if multiple nations are independently observing this, it suggests the phenomenon is real and reproducible. The question becomes, what is the actual nature of what we're observing? That's precisely what disturbs me, Nimitz replied. If this were simply equipment malfunction, it wouldn't be consistent across different technologies, different nations, different observers. But if it's a real physical phenomenon, then why didn't we notice it until now? Humans have been building increasingly sophisticated optical instruments for 300 years. Why does it take until 1942 for someone to notice that the horizon looks wrong? Dr. Rothstein had been waiting for this question. Admiral, I believe it's a threshold effect. Consider radio waves. They existed long before Marconi proved it, but humans couldn't detect them without specific technology tuned to specific frequencies. Similarly, this horizon phenomenon may have always existed, but required a specific combination of magnification, optical quality, and observational precision to become visible. The Mark 14 rangefinder, the Norden bomb sight, advanced submarine periscopes, these represent a technological threshold we've only recently crossed. But what are we actually seeing? Nimitz pressed. What is the mechanism? Dr. Chen pulled out her most recent analysis, a document filled with optical diagrams and ray tracing mathematics. I've been working on this question for the past 3 days. The only model that fits the observations is one where magnification itself introduces an observational effect that isn't present at lower magnifications. It's as if the act of looking more precisely changes the properties of what can be seen. Not because the optics distort reality, but because reality has properties that only become apparent at certain observational scales. That's not physics, Rothstein objected, not for the first time. It's precisely physics, Ashford interrupted. It's quantum mechanics applied to macroscopic observation. Werner Heisenberg demonstrated that observing a particle affects its state. What if that principle extends beyond subatomic scales? What if precision observation of any phenomenon introduces effects that aren't present in casual observation? Thomas found himself speaking before he'd consciously decided to, his voice carrying across the briefing room with unexpected force. Sir, permission to speak plainly? Nimitz nodded. Maybe we're asking the wrong question. We're trying to explain why the horizon looks different through advanced optics. But what if the real question is, which observation is correct? The enhanced view or the standard view? What if what we're seeing through the rangefinder is actually more accurate? And everything we've measured before was the distortion? The silence that followed was profound. Outside, the sounds of Pearl Harbor's reconstruction continued. Hammers, welding torches, diesel engines. The Navy was rebuilding its Pacific Fleet, replacing destroyed vessels, repairing damaged infrastructure. All of it based on assumptions about observation, measurement, and reality that were now being called into question. Admiral Nimitz finally spoke, his decision evident in his tone. Captain Morrison, I'm authorizing a formal investigation under Direct Pacific Fleet Command. Classification level, top secret, special compartmented information. Access limited to personnel with verified need to know. Codename. He paused, thinking. Operation Clear Horizon. You'll report directly to me, bypassing normal chain of command. I want 3 things. First, confirmation or refutation of the phenomenon through the most rigorous methodology we can manage. Second, if confirmed, theoretical explanation for what we're observing. Third, assessment of operational impact on naval warfare. He stood, signaling the meeting's end. Gentlemen, we're fighting a war across an ocean we apparently don't understand as well as we thought we did. I want to understand it better than the enemy does. Get me answers. March 10, 1942, Operation Clear Horizon established its headquarters in a requisitioned hotel in downtown Honolulu, far enough from Pearl Harbor to avoid casual observation, but close enough to maintain operational coordination. Thomas found himself promoted to Chief Petty Officer and assigned as Morrison's primary aide, a role that transformed him from observer to active participant in what was rapidly becoming the strangest investigation in naval history. Dr. Rothstein and Dr. Chen had spent the past 5 days designing an experimental protocol that would either confirm or refute the phenomenon through methodical scientific observation. The protocol was elegant in its simplicity, Conduct simultaneous observations of the same horizon segments using equipment with varying magnification levels, from naked eye up to the most powerful optics available, and measure any discrepancies with geometric precision. The test would be conducted from the summit of Mount Tantalus, a 2,013-foot peak overlooking Honolulu that provided unobstructed views of the Pacific. They'd requisitioned equipment from every available source: rangefinders, telescopes, theodolites, photographic equipment with lenses ranging from standard to extreme telephoto. 12 observation stations would be established at precise geographic coordinates, all focused on the same segment of Horizon 30. March 11, 1942. The convoy of trucks wound up the narrow road to Mount Tantalus in pre-dawn darkness, headlights painted blue to comply with blackout regulations. Thomas rode in the lead vehicle with Morrison and Commander Ashford, watching Honolulu's darkened streets give way to tropical forest as they climbed. The city was still adjusting to wartime reality: blackout curtains in every window, air raid sirens tested daily, a population that flinched at the sound of unexpected aircraft. Dr. Chen supervised Station 1, equipped only with surveying instruments and the naked eye, baseline observations using the simplest methodology. Station 2 through Station 5 used progressively more powerful binoculars, from standard 7-power civilian models up to military 20-power units. Station 6 through Station 9 deployed various telescopes, ranging from a modest refractor to a powerful 8-inch reflector borrowed from the University of Hawaii's observatory. Station 10 and 11 used naval rangefinders, a Mark 8 and a Mark 14 respectively. Station 12, under Dr. Rothstein's direct supervision, employed the Norden bombsight's optical system, removed from a B-17 and mounted on a specialized tripod. The experimental protocol was rigid. Every 15 minutes, all stations would simultaneously observe the designated horizon segment for exactly 2 minutes, recording measurements with a precision that would have seemed obsessive in any other context. They would measure horizon distance, apparent curvature, and any optical anomalies. Observations would continue for 12 hours, capturing data across varying atmospheric conditions as the sun moved from sunrise to sunset. At 0600 hours, as the first light touched the eastern sky behind them, Thomas called the first observation sequence. "All stations prepare for observation sequence 1. Mark your time, now." He moved along the line of stations, watching trained observers bend to their instruments with the focus of surgeons performing delicate operations. The Pacific stretched before them, vast and gray in the pre-dawn light, and somewhere in that immensity was a truth that refused to conform to 3 centuries of scientific certainty. Station 1, Dr. Chen called out her measurements first. Naked eye observation, horizon appears at approximately 23 miles based on height of eye calculation. No apparent curvature anomaly visible. Stations 2 through 5 reported similar results, standard observations matching expected values based on conventional geodetic models. Station 6, using a moderate telescope, hesitated. Lieutenant Murphy, an experienced navigation instructor, rechecked his measurements twice before reporting. "Sir, I'm seeing a slight upward curve at the horizon extremities, approximately 0.15 degrees deviation from expected horizon line. Could be atmospheric refraction, but the symmetry seems unusual." Stations 7, 8, and 9 reported progressively more pronounced curvature effects, each observer triple-checking their measurements with visible confusion. Station 10, using the Mark 8 rangefinder, confirmed the phenomenon with mathematical precision. Horizon curvature approximately 0.4 degrees at extremities. This is consistent with previous observations and inconsistent with standard Earth curvature models at this distance and altitude. Station 11, Thomas himself using the Mark 14 rangefinder, observed the now familiar effect with renewed wonder. Through the enhanced optics, the horizon bent upward at its edges with geometric precision, as if the ocean were a shallow bowl rather than a sphere. He called out his measurements, noting the increasing magnitude of the effect. Station 12, Dr. Rothstein at the Norden bombsight, took the longest to report. When he finally spoke, his voice carried a note that Thomas had never heard from the physicist, something between awe and fear. The bomb site's optical system shows horizon curvature of approximately 0.7 degrees at extremities. But there's something else. The enhanced optics are revealing what appears to be structure in the horizon itself. Fine geometric patterns, almost like, I don't have words for this. It's as if I'm seeing the horizon's architecture. Commander Ashford was at Rothstein's station immediately. She looked through the bomb site for nearly 5 minutes, her silence more eloquent than words. When she straightened, her face had gone pale. "Captain Morrison, you need to see this." Morrison spent 3 minutes at the bomb site, his expression shifting through confusion, denial, and finally, a kind of grim acceptance. When he stepped back, he looked at Thomas with eyes that had witnessed something that couldn't be explained by equipment malfunction or atmospheric distortion. "Continue observations as scheduled," Morrison ordered, his voice steady despite what he'd just seen. "I want documentation of every observation, every measurement, every anomaly. If reality is refusing to behave according to our models, I want to know exactly how it's misbehaving." The day progressed with mechanical precision. Every 15 minutes, 12 stations recorded their observations. The data accumulated like evidence at a trial where reality itself stood accused. By mid-morning, patterns emerged that defied explanation. The magnitude of the horizon curvature effect increased proportionally with magnification power, but not linearly. It followed a logarithmic curve that suggested threshold effects at specific magnification levels. Below 8 power magnification, the effect was barely detectable. Above 15 power, it became undeniable. Above 30 power, it revealed details that challenged fundamental assumptions about what a horizon should look like. Dr. Chen assembled the morning's data into charts that looked like medical records documenting a patient's steady decline. She spread them across an improvised table at 00:00, when they broke for a brief meal of sandwiches and coffee that nobody really wanted. "This isn't equipment failure," she said, her scientific objectivity finally cracking. "This is reproducible, consistent, and progressive. Whatever we're seeing is real. It's just not supposed to be possible." Thomas studied the charts, his mind racing through implications that expanded like ripples from a stone dropped in still water. "What if," he said slowly, "the horizon doesn't actually exist the way we think it does? What if it's not just a geometric line where Earth's curve meets sky, but something more complex? Something with properties that only become apparent when observed with sufficient precision? That's metaphysics." Dr. Rothstein started to object, but Ashford cut him off. "No. It's information theory. The horizon isn't a thing. It's a boundary between observable and unobservable space. Maybe that boundary has characteristics we've never noticed because we've never looked precisely enough, and maybe—" She paused, the implications clearly troubling her. "Maybe the act of observing it with high precision changes what's observable." The afternoon observations continued, but the atmosphere had shifted. What had started as scientific investigation had transformed into something else, a confrontation with reality's refusal to conform to human understanding. By 1700 hours, they had accumulated 12 hours of data from 12 stations, representing the most comprehensive study of horizon optics ever conducted. Dr. Rothstein compiled the final analysis by lantern light as darkness fell over the Pacific. His conclusions were brief and devastating. The horizon curvature effect is real, reproducible, and increases with observational precision. It cannot be explained by atmospheric refraction, equipment malfunction, or observational error. The effect suggests either 1. Earth's geometry differs from calculated models in ways we don't understand. 2. Enhanced observation introduces quantum-like effects at macroscopic scales. Or 3. The relationship between observation and reality operates according to principles we have not yet discovered. I recommend further investigation, though I confess I have no idea how to proceed." Captain Morrison read the analysis twice, then looked out over the darkened ocean where America's enemies were moving through waters that no longer obeyed the rules that centuries of navigation had established. "Proceed?" he said quietly. "Doctor, we're already proceeding. The war doesn't stop because we've discovered the universe is stranger than we thought. The question is, How do we fight when we can't trust our own observations? March 16th, 1942. Commander Ashford burst into the Operation Clear Horizon headquarters at 0730 hours, waving a decoded message that had arrived from Naval Intelligence's cryptographic section 30 minutes earlier. The intercept had been pulled from Japanese naval communications, broken through the painstaking work of code breakers who'd been attacking the JN-25 code since before the war. "They know," Ashford announced without preamble. "The Japanese Navy knows about the phenomenon, and they're ahead of us." The message, once decoded and translated, came from Vice Admiral Chuichi Nagumo, commander of the Kido Butai, the carrier strike force that had attacked Pearl Harbor. It was addressed to Admiral Isoroku Yamamoto, commander-in-chief of the combined fleet, and its contents made Thomas's blood run cold. Enhanced optical reconnaissance continues to confirm horizon anomaly reports from December operations. Naval Technical Research Institute analysis indicates phenomenon is reproducible across all advanced observation platforms. Recommend immediate review of all navigation and gunnery calculations. Current models may be compromised. Request permission to establish dedicated research group under Professor Hideki Yukawa coordination. Professor Hideki Yukawa. Thomas recognized the name from his pre-war physics courses, a theoretical physicist who'd predicted the existence of mesons and would eventually win the Nobel Prize. If the Japanese had someone of Yukawa's caliber analyzing the horizon phenomenon, they weren't treating it as an optical curiosity. They were treating it as a strategic priority. Morrison read the intercept 3 times, his jaw tightening with each reading. "Ashford, what else do we have from Japanese communications? Anything about their research progress or conclusions?" "Limited, sir. The Technical Research Institute uses a different code system we haven't fully cracked. But we've intercepted fragments suggesting they've been investigating this since at least mid-January. There are references to observation threshold effects and something they're calling scale-dependent geometry. The terminology suggests they're approaching this from a theoretical physics perspective, not just as a navigation problem." Dr. Rothstein, who'd been sleeping in his office to maintain work continuity, entered the room in rumpled clothes with calculations scrawled on his shirt sleeves. "If they've had Yukawa working on this for 2 months, they may have developed theoretical frameworks we haven't even considered. Yukawa's work on meson theory suggests he's comfortable with concepts that exist at the boundary between classical and quantum mechanics. He might see connections we're missing. Then we need someone of equivalent caliber," Morrison said decisively. "Ashford, contact the Office of Scientific Research and Development in Washington. I want the best theoretical physicists in America read into this program. I want them here within a week." "Sir," Thomas interjected, "with respect, theoretical physics won't win the war. We need practical applications. If the Japanese understand this phenomenon better than we do, what advantage does it give them?" The question hung in the air like smoke. Dr. Chen, who'd been reviewing the intercept over Ashford's shoulder, provided an answer that none of them wanted to hear. "Navigation and gunnery," she said quietly. "If standard observational models are wrong, then every calculation based on those models is slightly incorrect. Range finding, bearing calculations, torpedo firing solutions, bombing accuracy, all of it depends on precise understanding of distance, angle, and curvature. If one side understands the true nature of observation better than the other, they can make more accurate calculations. In naval warfare, accuracy advantages of even 1% can be decisive." Morrison walked to the window overlooking Honolulu, where palm trees swayed in the trade winds and the morning sun painted the city in shades of gold that seemed to mock the darkness of what they were discussing. "We need operational recommendations. Not in 6 months, not after we've built a complete theoretical framework. Now, what can we tell fleet commanders that will help them fight more effectively given what we know?" Thomas found himself thinking about the submarine crews, the bomber pilots, the gunnery officers. Thousands of sailors and airmen whose lives depended on calculations that might be fundamentally flawed. An idea formed, one that seemed obvious in retrospect. "Sir, we publish correction factors. We can't explain why the corrections are necessary, but we can provide empirical adjustments based on our observations. For every standard calculation that involves long-range observation, horizon distance, range finding, bombing solutions, we provide modified values based on the magnification level being used. Treat it as an equipment-specific calibration rather than a fundamental physics problem. Morrison turned from the window, and something like hope flickered across his features. Practical. Implementable. Won't require convincing skeptical commanders that reality doesn't work the way they think it does. Rothstein, Chen, how quickly can you develop correction tables? 72 hours, Chen said after a moment's calculation. We have enough data from Mount Tantalus to establish baseline correction factors for standard Navy optical equipment. It won't be perfect, but it'll be better than operating under false assumptions. Do it, Morrison ordered. And classification on those tables is absolute. We don't explain why they're necessary. We just issue them as updated calibration standards for advanced optical equipment. Let commanders think it's equipment refinement, not reality refinement. Admiral Nimitz arrived at 1000 hours, summoned by Morrison's urgent message. The Admiral listened to the briefing on Japanese awareness and the proposed correction factor solution with his characteristic calm, but Thomas could see the strategic calculations running behind his eyes. If Yamamoto has been aware of this since January, Nimitz said slowly, and they've had Yukawa analyzing it, they may have already incorporated corrections into their operational planning. That could explain some of the unexpected accuracy we've seen in their operations. He pulled out a report from his briefcase, an after-action analysis of the Japanese attack on Darwin, Australia, which had occurred just weeks earlier on February 19th. Japanese bombing accuracy at Darwin was exceptional, better than their Pearl Harbor performance. We attributed it to improved tactics and training. But what if it was improved calculations based on better understanding of observational physics? The implications settled over the room like a physical weight. The Japanese weren't just aware of the phenomenon. They might be operationally ahead, fighting with corrected models while American forces operated under false assumptions. Commander Ashford voiced what everyone was thinking. Sir, if that's true, we're fighting this war with one hand tied behind our backs. Every engagement where precision observation matters, and in naval warfare, that's every engagement. We're at a disadvantage because we're using incorrect models. Then we correct the models, Nimitz said with the finality of command decision. Effective immediately, Operation Clear Horizon becomes Pacific Fleet's highest scientific priority. Rothstein, Chen, you have unlimited access to any resources you need. Morrison, coordinate with all theater commands. Everyone gets the correction factors, classified as equipment calibration updates. Ashford, I want daily updates on any intelligence regarding Japanese research progress. He stood, preparing to leave, then paused. Gentlemen, Dr. Chen, Commander Ashford, we're 3 months into a war that will determine the future of human civilization. We're learning that the ocean we're fighting over doesn't behave the way we thought it did. That's terrifying. But it's also an opportunity. The side that understands reality better will win. Make sure that side is us. June 4th, 1942. Thomas stood on the bridge of the USS Enterprise as the carrier pitched through moderate seas northeast of Midway Atoll, and he watched history pivot on calculations that 3 months ago would have been impossible. The correction factors developed through Operation Clear Horizon had been distributed to the Pacific Fleet in April, classified as Enhanced Optical Calibration Standards, with no explanation of their theoretical basis. Most commanders had implemented them as routine equipment updates. Some had questioned them. None had understood what they truly represented. Now, as American dive bombers prepared to launch against the Japanese carrier strike force, those corrections were about to be tested in actual combat. Lieutenant Commander Wade McCluskey, commander of Enterprise's Air Group, studied his plotting board with the intense focus of a man whose calculations would determine whether his pilots found their targets or flew into empty ocean until their fuel ran out. Thomas had briefed McCluskey personally on the correction factors 2 weeks ago, explaining them as refinements to account for atmospheric distortion effects at high magnification. The corrections put the Japanese fleet approximately 11 miles closer than standard calculations would indicate, McCluskey said, marking the position on his chart. At the speeds we're flying and the fuel we're carrying, That 11 miles could be the difference between finding them and missing them entirely. The battle had already been shaped by enhanced observation. Earlier that morning, PBY Catalina patrol aircraft equipped with enhanced optics and operating under corrected navigation models had spotted the Japanese carriers at ranges that shouldn't have been possible under standard observation protocols. The sighting had given Admiral Raymond Spruce's, commanding Task Force 16, crucial hours to position his carriers for the attack. At 0900 hours, McCluskey's dive bombers launched from Enterprise's deck. 37 aircraft rising into scattered clouds that broke the morning sun into cathedral light. Similar formations launched from Yorktown and Hornet. 161 aircraft total, carrying the hopes of a nation that had been losing this war since December. Thomas remained on the bridge monitoring radio communications as the strike force flew toward contact. The corrections had been built into every aspect of the operation: navigation plots, search patterns, bombing calculations. But corrections based on observations nobody fully understood, attempting to compensate for reality's refusal to conform to classical models. At 10:20 hours, radio crackle resolved into McCluskey's voice. Have sighted enemy carriers. Attack commencing. Captain Morrison, who'd arrived aboard Enterprise specifically to observe how the corrections performed under combat conditions, stood beside Thomas at the communication station. Neither man spoke. There was nothing to say. Either the calculations were right, or 67 American pilots were about to die attacking the wrong piece of ocean. The reports came back in fragments broken by radio interference and the chaos of combat. Direct hit on carrier, second carrier burning, Japanese fighters heavy but we got through. Kaga is going down. By 1100 hours, the impossible had happened. 3 Japanese carriers, Akagi, Kaga, and Soryu, were burning or sinking. The 4th, Hiryu, would be hit by subsequent attacks and would sink before the day ended. The Kido Butai, the strike force that had attacked Pearl Harbor and terrorized the Pacific for 6 months, had been destroyed in the span of 6 minutes by dive bombers, whose calculations had been corrected for a phenomenon that officially didn't exist. Admiral Spruce's after-action report, which Thomas would help compile over the following days, noted that American air groups had achieved unprecedented accuracy in locating and engaging enemy forces at extreme range. It attributed this to improved training and recently implemented optical calibration procedures. It did not mention that reality itself had proven more complex than 3 centuries of physics had suggested. June 7, 1942, 3 days after the battle, Thomas stood again on Mount Tantalus watching the Pacific horizon with Dr. Chen and Dr. Rothstein. They'd returned to verify the phenomenon with post-battle data, to confirm that the corrections that had helped win at Midway were based on reproducible observations rather than fortunate errors. Through the Mark 14 rangefinder, the horizon still curved upward at its extremities with geometric precision that defied classical models. The phenomenon remained exactly as they'd documented 3 months earlier. Consistent, reproducible, impossible. We won a battle using calculations based on observations we don't understand, Rothstein said quietly. We've proven the corrections work operationally, but we're no closer to understanding why they're necessary. Dr. Chen nodded, her eyes still fixed on the horizon. The Japanese had similar corrections. We know that from intelligence intercepts. Both sides were fighting with adjusted models, compensating for something neither side could explain. The advantage went to whichever side implemented their corrections more thoroughly. We did, we won, but we're still fighting in darkness, using tools we don't truly understand. Thomas thought about the pilots who'd flown into combat that morning 3 days ago. Their navigation computers loaded with correction factors derived from observations conducted on this very mountain. They'd trusted the calculations without understanding their basis, and that trust had saved their lives and helped turn the war. Maybe understanding isn't what matters, he said. Maybe what matters is observation. Reality is what it is, whether we understand it or not. We observed it accurately, we adapted our models to match our observations, and we used that knowledge effectively. Isn't that enough? For winning battles, perhaps, Rothstein replied, but not for science. Science isn't just about practical application, it's about understanding. And we've observed something that suggests everything we thought we understood about observation, Measurement and reality needs to be reconsidered. Commander Ashford, who'd arrived by jeep 15 minutes earlier, joined them at the rangefinder. She'd brought news from Pacific Fleet headquarters. Operation Clear Horizon was being expanded, given additional resources, assigned more personnel. The corrections had worked too well at Midway for the Navy to ignore the phenomenon any longer. Admiral Nimitz wants a full theoretical investigation, Ashford announced. He's authorized recruitment of the best minds in physics, mathematics, and optical science. We're going to understand this, not just compensate for it. She paused, looking out over the Pacific where American and Japanese forces continued their desperate struggle for control of an ocean that refused to behave according to established rules. He also said something else. He said wars are won by the side that adapts fastest to reality, not the side most committed to their assumptions. We started this war assuming we understood how observation works. The Japanese started with the same assumptions. We both learned we were wrong, but we adapted faster. That's why we won at Midway. Thomas returned his attention to the rangefinder, watching the impossible horizon with eyes that had learned to trust observation over assumption. Through the enhanced optics, he could see what Dr. Rothstein had described, the faint geometric patterns in the horizon itself, structures that seemed to exist at the boundary between visible and invisible, as if reality had architecture that only revealed itself when observed with sufficient precision. Somewhere in the Pacific, American submarines were hunting Japanese shipping using corrected navigation models. American aircraft were conducting reconnaissance with adjusted range calculations. American surface ships were plotting courses that accounted for observational effects that classical physics said shouldn't exist. All of it based on acceptance of observations that challenged fundamental understanding. The war would continue for 3 more years. Operation Clear Horizon would grow into one of the largest classified research programs of the conflict, employing hundreds of scientists and producing thousands of pages of documentation that would remain classified for decades. The theoretical explanation for the horizon phenomenon would remain elusive, debated, never fully resolved. But the corrections would be refined, improved, integrated into every aspect of naval operations. By war's end, both American and Japanese forces would be operating under modified observational models, fighting battles that depended on calculations that their pre-war selves would have dismissed as impossible. The Germans, too, would develop their own corrections after U-boat commanders reported similar phenomena through their advanced Zeiss periscopes. The phenomenon would never be publicly acknowledged. The correction factors would be classified, their basis unexplained, treated as proprietary military technology rather than fundamental physics. Post-war, the research would be absorbed into other classified programs. The observations folded into Cold War projects exploring the boundaries of what could be known and measured. But on that June morning in 1942, standing on a mountain above an ocean where reality had proven stranger than theory predicted, Thomas understood something that would stay with him for the rest of his life. Human understanding of the universe was provisional, limited by the precision of available tools and the courage to accept observations that challenged cherished assumptions. The sailors at Pearl Harbor in '42 had glimpsed something at the edge of perception, not because reality had changed, but because humanity had finally built instruments precise enough to see what had always been there. The horizon curved upward through the enhanced optics, impossible and undeniable, a reminder that the universe kept its secrets until humanity developed the tools and wisdom to perceive them. Whether that perception brought understanding or just deeper mystery remained an open question. But it had helped win a battle, and in the summer of 1942, with the fate of civilization hanging in the balance, that was enough. Thomas stepped back from the rangefinder and looked at the horizon with his naked eyes. It appeared normal, a straight line where ocean met sky, behaving exactly as centuries of observation had established. Familiar, comfortable, wrong. He smiled slightly, understanding that sometimes the most important discoveries weren't about finding new answers, but about learning to ask better questions. The sailor who'd stood at Pearl Harbor in February, wondering why the enhanced horizon wasn't what it should be, had been asking exactly the right question. The answer, complex and troubling and still incomplete, had changed the war. Eventually, he suspected, it would change everything else too.